All right, so page 4 of the review. Right here is to solve the equation making the appropriate substitutions. I personally don't like to do substitution on problems like these. If they get really messy, I'll do substitution, but honestly, these aren't really all that bad. So if you just kind of think about it, I think you'll have a better understanding also if we don't do substitution on these particular ones. Now, if you're comfortable with that and that's the way you want to do it, then go for it. But the way I think about it is, you're doing the reverse FOIL, right? This is what the first two multiply to give you, then the outer plus the inner, right? And then the last two multiply to give you 4, right? So we're just unfoiling this. And so the way I get to x to the fourth power is it's going to be an x squared, because x squared times x squared is x to the fourth. Now I got to figure out how do I get a 4 and add up to -5. Multiply, you get -4, add up to -5. So it should be a -4 and a -1. And so if you look at that, that multiplies to give me a 4. And if I were to, the outer and the inner add up to a -5. Now what you'll notice is these are actually both the difference of two squares. Okay. So this should be able to factor into x plus 2, x minus 2. This factors into, oops, sorry, my pen's going a little crazy on me. Should be x plus 1, x minus 1. So let's see, x plus 1, x minus 1. And so I actually get 4 answers here. And so my solutions are -2, +2, -1, +1. And so there are my solutions right there. Okay, this next one's a little bit trickier because yes, you've got fractions, but it's not, it's not as bad as you think. So I'm still going to do it kind of the way I did the last one. Now, what you'll notice about these, the pattern is that the term that goes first, it's going to be whatever there is in the middle right there. So this is going to be x to the 1/4, x to the 1/4. And see, what happens is when you multiply those together, and I'll just kind of show you off to the edge. So if you have 1/4, x to the 1/4, you add exponents. So when you add, it becomes 2/4, which then simplifies to the x to the 1/2 power. So that's where that x to the 1/2 comes from when you're foiling it. X to the 1/4, x to the 1/4, you add them, and it actually turns into x to the 1/2. And so that's what's happening there. Okay, so now we got to figure out how am I multiplying to get the -10 by adding up to 3. And so it should just be a +5 and a -2. Okay. So we want to figure out what makes this, equal 0. So what we're going to do is we're going to take each one of these and set them equal to 0 and solve. All right. So here, let's see, we'll subtract 5. So we get x to the 1/4 equals -5. And then we're going to raise both sides to the power of 4. And so that's going to get me x to the power, or I'm sorry, -5 to the 4th power should give us 625. Okay. By the way, whenever you raise to an even power, there can be some unintended consequences, and we'll talk about that in a second. So here I'm going to add 2, so I get x to the 1/4 equals 2. And then I'm going to raise both sides, power of 4, power of 4. And so that's going to get me x equals 2 to the 4th power is 16. Okay, 16 works. 625 actually doesn't work. That's actually a bad answer. If you were to plug it in, raising to the 1/2 is the same thing as square rooting. So if you square root 625, that just turns into 25. So you'd have 25 plus something else, and then minus 10. There's no way that could equal 0. So that's actually a bad answer, okay? You know, on the exam, I probably won't give you something like that to where one of them doesn't work out, because in the notes we didn't quite. I don't think we ran into that too often. It's good to see it though, to see that you got to be careful and check your answers, okay? But I don't think I plan on giving you one that tricky, okay? Where not that this was a super hard problem, but that one of the answers didn't work. Anyways, you got to be careful. Okay, I think I have one more of these right here. Okay. So this one right here, this is I really like this question, so hint, hint. Okay, so on this one, once again, I'm going to kind of do it like the others. We're going to basically unfoil it. So once again, that middle guy kind of tells me that I'm going to have x to the negative 1, x to the negative 1 right here. And when you multiply that together, you add it, and it's x to the negative 2 power. So that's where that comes from. So now I got to figure out, what multiplies to give me negative 16, but then they can add up to negative 6. So it should be a minus 8, and it should be a plus 2. Okay? So we want to figure out, what makes this equal 0. So we're going to take each one of these and set them equal to 0 and solve. And if you know how to do some tricks on this, it's pretty simple. It's not going to be too bad. So let's see, x to the negative 1 minus 8 equals 0. X to the negative 1 plus 2 equals 0. So I'm going to go ahead and add 8 to both sides. All right, so here's the trick. Here's the fast way of doing this problem. You raise both sides to the power of negative 1. And so on the left side, see power to a power, you multiply negative 1 times negative 1. So you get x to the 1 power equals, and then here we don't like negative exponents, so I do need to fix this. And so the way I fix this is you take the reciprocal, so it turns into 1/8. And that's your answer for that first part. And if you were to plug it in, it would work out for you. Okay. Same thing with the next one. So we'll subtract by 2, subtract by 2. So we get x to the negative 1 power equals negative 2. And we're going to do the same little trick here. What we'll do is we'll raise both sides to the power of negative 1. So that will just turn that into x to the positive 1 power. And then here I got to take the reciprocal of negative 2. So it's going to be 1 over negative 2. And in this case, both of these should work. If you were to plug them in and try it, it should work out for you. Okay, so I got one more problem on this page. And on this one, the numbers are going to get kind of a little crazy, to be honest. On the exam, I will make it to where the numbers are much more nicer to work with. And you know what? I'm just going to go ahead and adjust this problem, actually, to make it a little bit nicer for us, too. Let's just go ahead and change this to f of like negative 3 instead of negative 13. The numbers get into like the thousands, and it's just kind of ridiculous. I'm not going to give you a problem like that. So you can expect something more like this. So all right, so here we go. So it's asking us to go ahead and evaluate this. If you really want to, you could plug it in and just do it by hand. But the faster way is just doing synthetic division and do the remainder theorem. So let's see, we're going to take 2, the negative 7, the 9, and the negative 3. We're going to take those, okay? And so we're going to evaluate it at negative 3. Oh boy. Let me see if I can undo some of this stuff. Okay, here we go. So we drop the first number down. 2 times negative 3 is negative 6. We add this together. That'll give us negative 13. Negative 13 times negative 3, that's going to give us positive 39. 39 plus 9, let's see, this can give us 48. 48 times negative 3 is going to give us negative 144, I believe. Let me see. Yeah, that sounds right. And then we add this together, and so that's going to give us negative 147. So it still gave us a pretty big number. But anyways, that's all you do. You just do your synthetic division, and the remainder tells you what what you're trying to evaluate, what it would give you. So if I would have used negative 13, this thing would have been like, I can't remember, but it would have been like in the tens of thousands. But anyways, I gave it something more like what you can actually expect on the exam. All right, so there's page 4. We got one more to go.